Good evening, everybody. We are about to merge two evil empires together, that being integers, what to do with positive and negatives, or the information we learned with integers, and fractions. So everything we've learned about fractions so far, adding, subtracting, multiplying, and dividing, we're going to couple that with all the rules that we learned for adding, subtracting, multiplying, and dividing integers. Remember, fractions are not integers because they're not whole numbers or the opposite of whole numbers. So, show no fear, and let's get started. You've got your handout with you. So, the notes today of doing a little differently. Instead of writing out very much, I'm just starting with several examples, and we're just going to write some notes out to the side of each example as far as what we're really, what we're doing for a particular problem. So on this first one, when you look at it and you see two negatives being combined, so negative 8/9 minus 6 and 9/11. I should be thinking about the rules for integers. I'm not thinking anything about fractions just yet. So the rule for this one is, and let's write, rule is same sign, add, and keep the sign. So really, I'm just going to do a little rewriting of the problem so that I can do what I already know, and I know I just need to add these fractions together, and then the answer is going to be negative. So I'm going to rewrite it. So I'm going to put a minus out here in the front, and either with big brackets or you could use parentheses, I'm going to just take 8/9 and add to 6 and 9/11. So we're adding the numbers, and then we're going to keep the sign. So let's write that down over here. So for this step, we just rewrite as addition, and put the negative sign on the outside. It's good to write down what you're doing so that later you know what happened. Now you just work what you've been doing with fractions, and then just keep bringing down that negative. And I'm going to keep the brackets or parentheses, whichever you use, on my problem until I get finished. So it's adding. I need a common denominator. So with 9 and 11, they have no factors in common, so I have to just multiply them together. So 9 times 11 is 99, so my numerator is 88. 6, and got to multiply top and bottom here both by 9, so I get 81. Now, be careful when you're writing an equal sign right next to a negative. You have to have some space in between, otherwise they sort of get, the negative will get gobbled up by the equal sign. So let's keep going. So I've got a whole number 6, got 99 for my denominator. I need to add 88 and 81. That's 169. And I need to do some simplifying here because 169 is bigger than 1. So I need more room. Hopefully you didn't write as largely as I did, but I'm just going to kind of ignore number 2 for just a second and keep working down the page. And I'll come back to number 2 in a minute. Well, what I like to do is keep my 6 here and change this to a mixed number. So I would have 169 divided by 99 That goes one time with 70 left over. Notice I'm still just writing the minus out here. I'm going to keep it out there until I get a single number. So I have 7 and 70 over 99. So it's like saying the opposite of 7 and 70 99ths is negative 7 and 70 99ths. So really, just combining two things that we've done before. No problem. So let's go ahead and add one more step up here. So once we rewrote it, from here, I'll just write add fractions as usual. It's not very good to see. And that's it. So sometimes it's just that easy. Well, let's try number 2, and I'm just going to erase this part. All right. Now, number 2 is a little more challenging. Well, it looks like it's going to be more challenging, but really, in terms of dealing with the positive and negatives mixed together, it's actually easier than the first problem. I don't really have to do anything fancy. I just need to multiply and figure out what kind of sign I need to have. Well, let's write the rule out to the side. If you're multiplying, let's just figure out what our answer is going to be. If you have a negative, when you have a negative times a positive, you're going to get a negative. And so then when you multiply a negative times a positive, you're going to get a negative. So I'm going to ignore the negative, but just put a negative out there for my answer because that's what the result's going to be. I suggest, instead of doing what I just did to determine the sign, that you actually just look at it ahead of time and think, I've got one negative sign. If you're multiplying a string of numbers and you count up the number of negative signs, if it's odd number, the result's going to be negative. So over here, let's just write the rule here. I'll say I have an odd number of negative signs. So the product is negative. Remember, a product is just the result of a multiplication problem. But that's not exactly how we learned the rule, but it works even if you just have 2. If you were to cover this one up and just think about these 2, you have an odd number of negative signs. You have 1, even when you're just addressing the 2 numbers. So you would still get the same result, negative. So it's actually a nice way of thinking about it. Well, so let's do it. I'm just going to put my minus out here and forget about it until the end. So we need to convert everything to improper. Remember, we're just thinking of this as like it's plain old 5 and 1/5. In fact, I'm going to write an additional step. It's like we're multiplying this. We no longer have the negative because I've put it out in front. So I don't have to think about it. Now we'll convert everything to improper. I'm going to have to try to write just a little bit smaller. So let's do it. Everything is improper. So we're supposed to already know how to do this, so I'll just kind of say it rather quickly. But 5 times 5 plus 1. So that gives us 26/5. When we convert here, we get 84 plus 1, 85 over 42. And 13 plus 5, we get 18 over 13. Now what you want to avoid, as we've been trying to teach, is don't just multiply straight across. That's a really, really bad idea with lots of scratch work. So we don't want to do that. So we want to rearrange instead. If you're a slasher, like I said, go ahead, but I'm going to stick with the way I like to do it, which is I write all the numbers as if I'm going to multiply across, and then on the bottom, since I know I can change the order, I purposely rearranged. So I think I want the 5 here. Yes, now I have lined up my common factors. 26/13. Those are both divisible, by 13. So you could just put a 2 on top. It means 26 divided by 13, or if you prefer, you can keep the 1 down there as well. 85 divided by 5 is 17. 18 and 42 are both divisible by 6. 6 goes into 18 3 times, and 6 goes into 42 7 times. Again, you can either put these ones down here or not, your preference. Before you multiply across, look and make sure that you have no more common factors in the top and the bottom. So 7 does not have anything in common with 2, 17, or 3, other than 1, of course. So now we're ready to multiply straight across. 2 times 17 is 30. Actually, it's easier to do 17 times 3, that's 51, times the 2, that's 102. And across the bottom, we get 7. So my final result would be negative 102 over 7. This is a good time to point out when you're writing a negative fraction, the negative can be in several places. Typically, when I write it in my work, I keep it on top, so it's kind of up here with the numerator. When you see it typed or in print in a book, generally it's right even with the fraction bar. We just call that out front. So it can either be up top, out front. It can actually be in the denominator, but that's a really bad idea. And typically, when it is there, people like to rewrite it. So putting it out front or putting it up with the numerator on top, either way is fine. So let's add on one more step over here. We identified our rule, and from there we just multiplied as usual. So I'll just put apply fraction multiplication rules. So there's a good example of a multiplication problem. Well, let's keep going. This one I like because it's got a negative and a positive. Well, let's think about our rules. We're not multiplying, we're combining, because you see that addition sign in the middle. So with adding and subtracting, we just, in general, I like to call it combining, because you have to decide if you need to actually add or subtract in order to work it out. So I've got unlike signs, so I need to subtract, use the sign of the larger. So I'm just going to write my rule over here. The rule is subtract, and I'll abbreviate. Excuse me, use the sign of the larger. Well, before I ever start, I know I'm going to subtract the large number, I'm going to subtract the smaller number from it. So I'm going to take 12 and 11/20, and I'm going to subtract 8 and 5/8, because that's what the rule says to do. And the outcome has to be the sign of the larger. Well, if you look at your original problem up here, the larger is the negative, or 12 and 11/20, so the whole thing's going to be negative. I apologize, excuse me. So now we're just going to work this subtraction problem and drag the negative down the page. So let's write our rule over here. Now we're going to work subtraction problem, and then just bring down the negative. That's really it. If you try to get creative with it and try other strategies, you'll find that you might run into a little bit of trouble. So I don't advise it, but should you decide to do something differently, I'll show you this problem. Well, I'll just tell you now. It's not only the 12 that's negative, but it's the 11/20 as well. So one option that you might have, and I'll just show it up here just a little bit. This means the same as negative 12 minus 11 twentieths plus 8 plus 5/8. If you wanted to get a little creative, you could combine negative 12 and 8 and get your result, and then work on negative 11 twentieths and positive 5/8. The trick there is, well, I just think makes it harder, but some of you work your fractions in some different sort of ways, as I've noticed. I'm teaching it the way I'm teaching it because I think that works best and is most consistent with what we've done previously. So we're just sticking with what we know, basically. So I can't actually subtract just yet. Common denominator would be what, 40? So let's rewrite both of them. So top and bottom get multiplied by 2. Top and bottom over here get multiplied by 5. 25 is bigger than 22, so I have to borrow. With this 12 drops down to 11. My new numerator is the sum of these, so that's 62 over 40 minus 8 and 25 over 40. Same thing we've been doing for the last unit we did. So let's subtract. We've got 11 minus 8, 62 minus 25, that's 37 over 40. I don't want to stop and leave my answer with the negative outside of parentheses, so it is important to go ahead and, drop it off. I just don't like to drop it off until the very end. So negative 3 and 37 40ths. And again, you'd still get there if you worked this problem, and some people might find that better. That's up to you. I'll let you play around with that and see me if you try it and you run into some trouble. All right, let's keep going. Now we're graduating up to where we have more than one multiplication and division problem to do. Get rid of that. So typically when we get here, and same thing should apply now, we would maybe put two of them together and then the other one, and that's still a perfectly fine idea. In fact, when I see this problem, I notice that the second two fractions are both positive, so I would want to rewrite it, and I'm just going to insert some parentheses here. That's just to let me and whoever's looking at my work know that I'm going to add those together first. So I'll just keep bringing this down, this negative 42, until I get my result over here. Well, so that's 6 and 3/6 plus 2 and 5/6. Had to get a common denominator. Just keep bringing down. And that's 8 and 8/6. And keep bringing down. 8/6 is 4/3. Then I just drop the parentheses there and keep bringing down that first one. 4/3 is, actually I'm going to keep those for a minute. That's 1 and 1/3. You can go directly to 9 and 1/3 if you'd like. I just want the notes to be clear. Plus 9 and 1/3. So we're not finished, but we might stop and write over here what we've done so far, since I'm going to have to extend this page. So I'm making a note here that we're going to work 2 at a time. And you have to be a little strategic about what you're choosing. Could I have worked on the first two? I could have, but that would have been at least a little bit more work. I'd have to I'd get a negative, and then I'd have another negative plus 2 5/6. So I think the way we approached it is actually better. So let's say right here we wanted to add the two positive fractions first. I don't have to do that. I'll say positives first. Under here, I'll just write, because that's easier, not because you have to. You can add these together in any order that you would like. Let's write one little note here, just kind of a beware. If you do decide to do things out of order, no matter what, this 42 5/9 has to be negative. So you have to be careful. Some of the problems could be a little more challenging, and we'll talk about that. But I'm just going to write here, do not ignore the signs of each term. And what I mean by term is, this is a term, 6 1/2 is a term, 2 5/6 is a term. So the things strung together with the addition and subtraction, those are the terms. So this is something I'd really want to emphasize in my notes, especially for those of you who like to go about it in ways different than what I'm showing you, which is fine as long as you mathematically know that what you're doing is okay. All right, so I'm going to extend this page a little bit, and let's keep going here. So now it's like we have a whole new problem again. So I want to identify the rule. So it's like a new problem. Now the rule is I've got a negative and a positive, so I've got unlike signs. I want to subtract, use the sign of the larger. So let's just write that. Our rule is unlike signs, subtract, use sign of larger. So the sign of the larger is negative, so I'm just going to stick a big negative out here. And inside, I'll work on, I've got to rewrite this as a subtraction problem. You may find that you might actually need to write the rule out to the side when you're applying it. I'm writing it in the notes. You don't have to write that in your work, of course. I'm just writing it to help keep you a little straight. All right, so let's keep going. So let's see, we need a common denominator. So 9. That would be, keep that one the same. 1/3 is 3/9. Now let's subtract from here. I don't have to borrow because 3 is smaller than 5, so I've got 40. 5 minus 3 is 2. Oh, wait a minute. Found my mistake right here. I have a 42, and then all of a sudden I started writing 49. Well, that was silly. I don't know what I was thinking there. 42. So now I need to subtract 42 minus 9, which is actually 33. So my result is negative 33 2/9. I'm hoping you can really appreciate the level of review that you're getting over adding, subtracting, multiplying, and dividing these fractions. Gives you good work. You could even write over, when you write the rule, what your result's going to be. Like the result is going to be negative. But I want to see this negative, coming down the whole way with your problem. Don't just try to remember and throw it in at the end. Remember, we write equivalent steps, one underneath the other. You might want to stop the video and see what you can do with the last two problems, number 5 and number 6, and then come back and maybe check. Or you can just stay with me and we'll keep going. And I know this video is long. but I just really wanted to give you numerous examples. So hang in there. Now this one's got a mixture of of multiplying and subtracting. So you've got to think about your gems, which is your order of operations. So must use, we called it gems. G is grouping, E is exponents, M is multiply, divide, left to right, S is subtract and add, left to right. So that tells us we have to multiply first. So multiply first. That's not optional. So we'll just work the multiplication problem and then take a look at what we have, because these are both positive. So we don't need to do anything fancy, and we'll keep bringing down the other. So 7/15 is good already. And then 22 plus 8 is 30. I'm going to keep that in parentheses just as kind of a reminder that that's lumped together and that I want to take care of it before I do anything with the 9 and the 17/22. You can't just drop that off and reinsert 9 and 17 20-seconds later in the problem. So you keep bringing it down. So I take a look at this. I can simplify. If you're a slasher, I'll just do it that way here. 15 goes into itself once. 15 goes into 30 twice. So if I multiply across right now, I've got 14/11. So I've got 14/11 minus 9 and 17 20-seconds. Now when you get here, this is when you want to, it's like you've got a new problem to think about, and you need to figure out what rule applies. And by rule, I mean what integer rule applies. So hopefully everyone can recognize that 14/11, if I were to convert it into a mixed number, which I have that option of doing, then it would be smaller than 9 and 17/22. But if you don't recognize it, you might go ahead and change it. Since it's a subtraction problem, I'm going to choose not to leave this as 14/11, even though I could. So it goes one time with 3 left over 11. When you see it like this, you're going to definitely know that which rule is going to apply. So you have unlike signs. You have a positive here, a negative here. So you're going to have to subtract and use the sign of the larger. So I know my larger number is negative, so it's going to be a negative out in front, and then I need to subtract the larger value minus the smaller 1 3/11. So let's write down, before we go any further, what we've kind of done right there. So once we got right here, we came out here and I changed 14/11 to mixed, only because I already had a mixed number, and otherwise I'm going to have to multiply 9 times 22 and add 17, and we've just learned that adding and subtracting mixed numbers is easier than getting big improper fractions. Right here is where I decided on the rule. It was unlike signs. Oops, let's write rule. Unlike signs, so you subtract, use sign of the larger. So now we're just sort of back to regular old problem, no big deal. This one's even pretty easy to convert. So my common denominator is 22. So I'm rewriting it. 3 times, I read my writing, yeah, that's a 3. 3 times 2 gives us 6. Now when we subtract, we don't even need to borrow. So I've got negative 9 minus 1, 17 minus 6 over 22. And we should notice that 11 22nds is a half. Swing over here. So it's going to be negative 8 1/2. Just working out the subtraction. All right, last one. You're hanging in there. You're doing great. Last one over here. Well, these are easier. No mixed numbers to worry about. Go ahead and get rid of that. Clean it up just a little bit. So on an addition problem, initially right now, hopefully you can recognize which one is larger, but you don't have to decide right now which rule to use. You can wait until you get a common denominator, and then you can decide. So I'll just pretend I don't know which is bigger, and by bigger I mean 5/6 or 9/14. 5/6 is obviously bigger. But if I don't know that, then the first thing I would think about doing right here, if I don't know what 14 and 6 go into, or the least common multiple, remember you can come over to the side and do your ladder method. Remember, you can put anything out here that they have in common. So that'd be 7 and 3. You make your L, so your LCM is the product of everything in the L. So 21 times 2 is 42. And you go, oh yeah, that's right. It's 42. So 14, if you don't have to do extra division. Remember, here's the 14, the 7 and the 2 right here. And so the missing factor is 3. So on top it's 9 times 3, 27. Over here it's 42. You had to multiply the denominator by 7, so you got to multiply the numerator by 7. So remember, we still haven't done anything about this negative just yet. But clearly, if you hadn't discovered it before, 35 over 42 is bigger than 27 over 42. So at this point, I definitely ought to be able to write my rule. So different signs, my integer rule is unlike signs, subtract, use sign of the larger. You really don't have to write this rule out on your homework. You're just reiterating it each time so we can get it straight. So now that I know my result is going to be negative, because this is the larger one. So I need to take the larger, as we said in our rule, and subtract. There's the subtracting part, and then we're just use the negative because that one was bigger. I know every example we've had, the sign of the larger has been negative. Remember, that's not always the case. Sometimes it actually will be positive. So bring down your minus, and this is just some easy subtraction. Just 35 minus 27, which is 8. Don't forget to simplify. So at the same time I'm simplifying, I'm dropping off those brackets. I divide top and bottom both by 2. And my final result is negative 4 over 21. And there you go. Just plan to take some time on your homework and to be patient with yourself. If you need to keep the rules out for integers, since we still need practice with that, that's fine. But if you can do the work without any notes about the rules for integers, that would be fantastic. So have fun. Good night.